Okay, let's go ahead and move into 10.7, factoring special products. So we've dealt with special products and uh, before, and actually both of these you've seen at least going the other way, but now we're going to be factoring. So instead of um, going through and multiplying, so normally we would have something like this if we had x minus 2 times x plus 2, and we had to multiply those together. We could still FOIL those, but there's also, if there's remember that if there's only the difference between the plus or the minus, then all we have to do is just multiply the first terms and the last terms. We don't have to worry about the middle terms because they cancel. So now we're going the opposite way. So now we have x squared minus 9. So the rule is if both of the terms, remember these are terms here, we have two terms there. If both of the terms are squares, perfect squares, meaning in this case you'll notice it's x times x, and in this case it's 3 times 3. It has to be exactly the same for both of the variables, meaning that it has to be x times x. It can't be like 2x times x. And this has to be 3 times 3. It can't be 3 times 4. And so if we have this method and we have a minus sign in between, that's where the difference comes in, then this factors directly down to x plus 3 times x minus 3. Of course, you could have put the minus sign first and the plus sign second, but notice in the difference of squares that the signs are opposite. And notice that I get those values here, these right here, based on the two x's, and then this one based on the two 3's. So that's how I kind of look at that when I'm picking that up. Okay, so anyway, so that's how we factor it down. So now we can start recognizing some of these here. So notice in this particular case, I can see the 4y squared, and I can see the minus 25x squared, and I can see this is a perfect square. How do I know that? Because that is 2y times 2y. Make sure it has to be exact on both of them, and it has to multiply out to this whole term. And this one over here is 5x times 5x. Notice that we have a minus sign, therefore it's a difference. And so I can easily write this as 2y minus 3. Whoops, no, I put 3. I think I was looking at the problem above. 2y minus 5x times 2y plus 5x. So that's what I can have when I have those two there. So that's how I write that out. And that's it. That's all we have to do is just write it out in this particular way. So notice this one. These are perfect squares, both of the terms. That's 3x times 3x and 4 times 4. However, that's a plus sign. Since it's a plus sign, we cannot factor it. So notice that the difference between having a plus sign or a minus sign there is that if it's a minus sign, it factors. If it's a plus sign, then we cannot factor it. Okay, so let's do some problems. R squared minus 9t squared. Notice that we have the minus sign there, first thing that we check for. Then we check for the two squares. When you're trying to recognize these problems, notice they're always going to be binomials. They're not going to be trinomials, meaning that they only have two terms, not three terms. This is r times r. This is 3t times 3t. So it immediately factors down to r minus 3t times r plus 3t. Okay, 4h squared minus 25. This is 2h times 2h. This is 5g times 5g. We have a minus sign there, so it factors down to 2h plus 5g times 2h minus 5g. And notice that I'm kind of switching between where the plus and the minus goes. Minus I put first, plus I put first. It doesn't matter because with multiplication, 2 times 3 is the same thing as 3 times 2, so it doesn't matter what order I'm putting this multiplication in. There's a multiplication right in the center there, and so it doesn't matter which way I put it. Okay, 20q squared minus 5r squared. Now notice that these are not perfect squares, so that's 20. You can't think of a number that multiplies by itself to get 20. You have 2 times 10, 5 times 4, that's about it. 5 only has 1 times 5, so it won't work. However, if you notice that we have a common factor in both of these numbers, meaning I can divide out a specific number. So notice what number goes into both 20 and into 5, and that would be 5. So what I can do is I can take out a 5. Now, when I say take out a 5, that means I'm going to divide out a 5, but I'm going to put that 5 out in front. And so 20 divided by 5 is 4q squared. 5 divided by 5, of course, is 1. So I'm left with this, 5 times that. Now, remember that if I multiply it back out, I should get the same thing. So I have this here. That is now a difference of squares. I have 2q and 2q, and I have r and r. And so I end up with 2q minus r, 2q plus r, and you notice that I have my 5 sitting out here, so this would be my final answer. And that's how we do difference of squares. We're next going to do perfect squares, which is a little bit more complicated and a little bit harder to recognize.